Alright, part 2. I'm not sure what happened in the previous video, but I got cut off for some reason, so this will be a two-parter. Alright, I was on this example when things got a little weird last time, so I'm going to pick up here. 3q minus 4 times 3q minus 4. Notice that these two binomials are identical, and if we were to FOIL them out, we would have 9q squared minus 12q plus 16. And we would be able to combine those two terms in the middle, the oi, and they would actually then double to become a negative 24q. And that would give us 9q squared minus 24q plus 16. Another example would be 2p plus 5 times 2p plus 5. Again, they're identical. We could use FOIL. If we did, we'd have 4p squared plus 10p plus 10p plus 25. We would see that those two middle terms would again combine, and 10p plus 10p would give us a 20p, which is again doubling those two middle terms. We would then have 4p squared plus 20p plus 25. Okay. Now, be very careful in the notation of the problem that is given to you. If you are given a problem in the form 2p plus 5 squared, this actually means 2p plus 5 times 2p plus 5. A mistake that a lot of students make is that they think, oh, I'm going to distribute that exponent of 2 to everything on the inside of the parentheses. Don't do it. You were allowed to do that in the beginning of this unit because everything inside the parentheses was connected with multiplication or division. But because you have this addition here, you are not allowed to do that. It means 2p plus 5 times 2p plus 5. So make sure you're not falling for that trap and watch out. At this point, you would then proceed to FOIL, or in a second, you're going to see what the actual shortcut is. You would follow the shortcut. Okay. Now, the shortcut is that if you have two binomials that are identical to each other, that are being multiplied by each other, you can square the first term, square the last term, and that middle term is going to be 2 times the first times the last. Now, realize that sometimes you will see a plus b squared or a minus b squared. Sometimes you will also see it written as a plus b times a plus b, and sometimes you will see it as a minus b times a minus b. So there are a number of ways that you could see this. Okay, let's try a few of these. Remember that 3x plus 7 squared really means 3x plus 7 times 3x plus 7. At this point, you could absolutely FOIL it out. Remember, when in doubt, FOIL it out. Or if you recognize that these are perfect square binomials, that you could use the shortcut, we would square the first term and get 9x squared. We would square the last term and get 49. And we would multiply 3x times 7 and get 21x, and then double it to get a 42x, and voila, we have our answer. If you were to FOIL this out, you should get the exact same answer once you combine your like terms in the middle. Let's try another one. 2x minus 5 squared. This would be 2x minus 5 times 2x minus 5. Double that first term, it would give us 4x squared. Double that last term, it would give us 5. 2x times negative 5 would give us a negative 10x. Double that, it would give us a negative 20x. And there is our answer. Okay. Now, this one is 4x plus 1 times 4x minus 1. Think back to our first shortcut. These ones are very close to being the same, but their operators, their signs are different. So remember that in this case, our OI, our middle terms, are actually going to cancel each other out. And this is a difference of squares, which means that our sign in the middle is automatically going to be subtraction. Square that first term, we get 16x squared. Square that last term, and we get 1. These ones are my favorites. Okay. And that's it for multiplication of polynomials. I'm going to switch over to the next PowerPoint, which is division of polynomials. Okay. Now, similar to the way in which you had already actually seen multiplication of polynomials and you just didn't realize it, you have actually seen division of polynomials, okay? You've already seen something like this earlier in the unit, okay? And in this case, we went ahead and we did 25 divided by negative 5, and that was negative 5. We did r cubed over r by subtracting the exponents. That gave us r squared. And we did s to the 7th over s cubed by subtracting the exponents. And that gave us s to the 4th. This was division of a monomial by a monomial. Okay. Now, we're going to take that same knowledge and extend it just a little bit further. Okay? Realize that if you have fractions, whether you are adding them or breaking them apart, that the base, the denominator, is going to stay the same, but the numbers on the top, the numerator, can be separated out. Okay? If we're dividing a binomial by a monomial, so let's say we have 2 terms on the top, 1 term on the bottom, we can rewrite that so that each term in the numerator is being divided by each term in the denominator. So, for example, if we had 21p squared plus 14p over 7p, it looks intimidating, but we can break it down into smaller pieces. We can say that that's 21p squared over 7p plus 14p over 7p. So this 7p that's in the bottom belongs to each piece that's in the top. And then we've just got 2 little miniature problems here. 21 divided by 7 is 3. P squared over p is p. 14 divided by 7 is 2. And then right here, my p's are just going to cancel. Okay. Same thing's going to happen when we divide a trinomial, 3 terms, by a monomial. But this time we're going to break it down into 3 mini problems. 15x squared over negative 3 plus 9x over negative 3 minus 3 over negative 3. So that negative 3 that's on the bottom belongs to each piece on the top. Okay, 15 over negative 3 is negative 5. My x squared just stays x squared. 9 over negative 3 is negative 3. My x just stays x. And now here, realize that a negative and a negative becomes a positive 1. Okay. Same thing happens here. We're going to divide this into 3 parts. Oops. 8x squared y over negative 2y minus 4xy over negative 2y minus 2y over negative 2y. Okay, 8 over negative 2 becomes a negative 4. My x squared stays x squared, and my y's are going to cancel. Negative 4 over negative 2 becomes a positive 2. My x stays x, and my y's will cancel. Negative 2 over negative 2 becomes a positive 1, and my y's are going to cancel. And voila, there's my answer. Okay, this time I have a binomial divided by a monomial. Pause this one, work it out on your own, and see if you match up with my answer. 4p squared plus 8p to the 4th was the answer I got. It's really important to remember that you are dividing the coefficients, the numbers that are in front, but that you are subtracting the exponents. Okay, and that's it for division of polynomials. That section's pretty straightforward. It really is just the same as what you learned before. You're just breaking it down into those little miniature problems.